In this video, we're going to be solving nonlinear systems of equations. So first off, let's talk about what we mean by nonlinear system. A nonlinear system of equations is a system in which one or more of the equations are not linear, which is exactly what it says, are not linear. And if it's not linear, then that means it could be quadratic, it could be a parabola, it could be an ellipse, could be a hyperbola, could be any of your conics. So remember that. The solution to a nonlinear system, the solution set to a system of equations is a set of points in which the equations intersect. It's where they cross. So that's all we're looking for, is where do the equations cross. There can be one solution, multiple solutions, or no solutions. Now, let me preface this by saying this is probably the worst way of solving these systems. The only reason we're going through this is to give you extra practice on graphing, and that's it. Just reminding you on how to use transformations, how to graph lines, how to graph your conics. That's the only reason we're solving it like this. Desmos would be a great resource, or we'll talk later about how to solve these algebraically. But let's start out by trying to graph these and seeing where they cross. Now, one method that we can use for graphing, y equals negative x squared plus 7, we know that's a parabola, and we see two transformations, here and here. We always do our stretches, compressions, flips first, and then we do all of our translations. So what we could do here is we could actually just graph y equals x squared. We know what those graphs look like 0, 0, 1, 1, negative 1, 1. We know what's on those. We could take all those points, flip it across the x-axis, flip it vertically, and then move them up 7. So like the point 0, 0 that would normally be here, flip it across the x-axis, which doesn't move it, and then move it up 1, 2, 3, 4, 5, 6, 7. And we can do that for all the points. Another point that's on y equals x squared is 1, 1. Flip it across the x-axis, which would be down here, and then move it up 1, 2, 3, 4, 5, 6, 7. Do the same thing. Negative 1, 1 is also on the original. Flip it across the x-axis and move it up 7. And you can already see your axis of symmetry. Another point on the original equation is 2, 4, which is here. Flip it across the x-axis, which moves it down here, and then move it up 7, which is 1, 2, 3, 4, 5, 6, 7, which is right there. Now erase this point so we're not confused. Then you can use your axis of symmetry, and you know there's going to be another point over here. Now let's get us maybe one more set of points here. I know that 3, 9 is normally on it. Well, that means 3, negative 9 flips it across, and then when you move it up 7, it moves it to here. And then you're going to have another point symmetrical to it, which is over here. So there's your parabola, y equals negative x squared plus 7. Now the second equation, y equals x plus 5, that's a simple line. Y equals mx plus b form. You have a slope of 1, a y-intercept of 5, so go up to 1, 2, 3, 4, 5, and rise 1, run 1, we see a point of intersection there. Or go down 1, left 1, we see another point of intersection there, and there is the line. So therefore, my solutions would be this point and this point, which is located at negative 2, 3. And my other solution would be 1, 2, 3, 4, 5, 6. So my solutions, I should have put them down here, negative 2, 3, and 1, 6. Now, if these are truly solutions, you should be able to plug them into both of these. And I'm just going to show you with one of them. We can plug in the point negative 2, 3. When I plug in negative 2 here, I get negative 4 plus 7, which gives me 3. So negative 2, plug it in, I get 3. When I plug in negative 2 here, negative 2 plus 5 gives me 3. So negative 2, 3 is on both, so therefore it has to be a solution. Now another method, if you have a parabola, here's another option. You can find your axis of symmetry. If you don't remember, x equals negative b over 2a. So in this case, negative b would be 8 over 2 times a would be 4. So my axis of symmetry is going to be x equals 2. So therefore my vertex is going to be 2, comma, and I can plug that in. That'd be 2 times 4 is 8, minus 16 plus 3 would be negative 5 when you do all that work. So 2, negative 5 is going to be your vertex. And I've plotted that point there. And then to find other points on your parabola, you could simply take values to one side, maybe plug in 1 and 0 and negative 1. And when I plug those into my equation, here's what I get. And there's what I got. And there's the 3 points. And remember, since your axis of symmetry, here's my vertex. That means that once I plug those in, I've actually got more points on this side. So I could just mirror image those across my axis of symmetry, and now I have my parabola. And then we look at our second equation, which is again a line, slope of negative 2, y-intercept of negative 1. So here's my y-intercept, down 2 over 1, down 2 over 1, down 2 over 1 is going to be, well, I did a positive 1 instead of a negative 1. Let's try that again. My y-intercept is a negative 1. You go down 2 over 1. There's a point of intersection. Do it again. There's another point of intersection. So therefore, when I draw my line, my points of intersection are here and here. That's the common points. So that would be located at 1, negative 3. And the second point of intersection is my vertex there, which was at 2, negative 5. So there's the two solutions, and you can plug those in to check them. Number 3. Again, we have another parabola. We can find our axis of symmetry and our vertex by doing negative b. That'd be negative 6 over 2 times a would be 2. So negative 3 is my axis of symmetry. So my vertex is located at negative 3, comma. Plug that in, you get 9 minus 18 plus 4. 9 minus 18 is negative 9 plus 4 is negative 5. So my vertex is at negative 3, negative 5. And there's that point. We can use our points on either side. Let's say negative 3, it'd be easy to plug in negative 2, negative 1, and 0. And when I plug those into my original, here's what I get. And then I can just, again, simply mirror image those across to the other side of my vertex, and there is my parabola. Now, another good method we could have used here, this would have been very easy to get into transformation form and to use transformations to clean that up. Either way would have been fine, but there's your parabola. Next up, our second equation, let's do it in a different color, is a line. Let's move our x over, and you have y equals negative x minus 2. So you have a y-intercept of a negative 2, and you have a slope of negative 1 over 1. So that's a downhill line, so it's going to look something like this. You see a point of intersection there, and we should have another point of intersection right there. Now, real-world situations, you're not going to have nice, neat, whole number points of intersection, which, again, is another reason graphing doesn't work out as good. So there's your 2 points of intersection. You don't even have to finish graphing the line. So negative 1 is 1, and the other one's at negative 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, negative 6, comma 4. Next problem. Now we will solve this one. We'll get this one in transformation form. If you don't remember, step number 1, move the 8 over. So that's y plus 8 equals x squared plus 2x. Let's complete our square by halving and squaring. Let's add 1 to both sides. And I'm now going to factor, and that gives me x plus 1 squared, and this is 9. So let's move the 9 back over, and there's your transformation form. Now this is your y equals x squared parabola. That's just been moved left 1 and down 9. So what I would do is move left 1 down 9 and pretend like this is your origin right here. And just graph it like you would your x squared. You would have the point 1, 1, the point 2, 1, 2, 3, 4, the point 3, and then go up 9. And you could go over 4 and up 16 and then mirror those points. Again, just every point that's on your original y equals x squared parabola has just been moved left 1 and down 9. So again, just treat this like it was the origin. Go over 1 and up 1 like you're going to 1, 1, over 2 and up 4 like you're going to 2, 4, and there's your parabola. And again, your second equation is a line. It's both x to the first and y to the first. So what I would do is take my minus y, move it over here, move the 5 over here. It gives you 4x minus 5 is equal to y. Slope's 4, y-intercept's negative 5. So let's go from there. 1, 2, 3, 4, 5. Rise 4 and run 1. Goes up 1, 2, 3, 4 and over 1. Up 1, 2, 3, 4 over 1. Up 1, 2, 3, 4 over 1. Now I'm going to have to graph my parabola a little bit further just to see. 1, 2, 3, 4, and left one. There's my point of intersection there. But my parabola, I'm going to have to extend it on a little bit further. Now, let me remind you also, there's going to be patterns with these parabolas. Notice from this point to this point, I went up 1 and over 1. From here to here, I went up 3 and over 1. So I went up 1, up 3. Here, from here to the next point, I went 5 and over 1. So I went up 1, I went up 3, I went up 5. Guess what? For the next point, you're going to go up 7. 1, 2, 3, 4, 5, 6, 7, and over 1. Then you would go up 9 and over 1, and so on and so forth. But that's going to be your next point of intersection right there. So you can also use those patterns to graph your parabolas. And you can connect your dots for your line right there if you would like to. So there's your line, looks something like that, but your points of intersection is what you're interested in. That would be this point, which is located at -1. Well, it's the vertex, which was -1, -9. Let me try to clean that up some. And your other point of intersection was located at 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, I believe. 3, 7. Okay, next one, number 5. Now this one would be very easy to graph with your transformations. You're going to take your y equals x squared parabola, which is normally here, 1, 1, -1, 1, 2, 4, here, and you're just going to move every point down 9. So your vertex is now here. These 2 points will be here and here now. So go over 2 and up 1, 2, 3, 4. Go over 3, 1, 2, 3, and up 1, 2, 3, 4, 5, 6, 7, 8, 9. So it jumps up to here. Let me erase the originals. So again, just take your y equals x squared and move everything down 9 units. That's that transformation. Now, once you get here, again, you can use that pattern. Up 1 over 1, up 3 over 1, up 5 over 1, up 1, 2, 3, 4, 5, 6, 7, and over 1. And then you would have another point mirror image with there. There's your first parabola. Now your second parabola, y equals -x squared minus 6x minus 9. Let's see if we can get that into a transformation form. Let's factor the negative out to begin with. You have x squared plus 6x plus 9. That actually factors. That's a perfect square. So that's going to be x plus 3 squared. So this is your original parabola. We're going to flip it, and we're going to move it left 3. So every point 0, 0, we're going to flip it and move it left 1, 2, 3. The point 1, 1, we're going to flip it and move it left 1, 2, 3. The point -1, 1, we're going to flip it and move it left 1, 2, 3. There you go. The point 2, 4 that's on your original parabola, which is here, we're going to flip it 1, 2, 3, and moves it here and move it left 1, 2, and 3. And then you can mirror image that across. Here's your vertex. So you can mirror image that across the vertex. And now you could actually use patterns. Down 1 over 1, down 3 over 1, down 1, 2, 3, 4, 5, and over 1. And you can mirror image that as well. That's going to be, let's see, here's my vertex line, axis of symmetry. So I'm going to have it right here. And there's your new parabola. Let me erase some of this mess that I just drew and connect our dots. And there's, again, our new parabola. So my points of intersection would be here and here. Actually, the 2 vertices on the parabola, the 2 parabolas. So one of them's at -3, 0. And the other one's located at 0, comma, I believe that was -9. There's your 2 points of intersection. Okay, the next one. Again, on number 6, you can do it any of the ways that I've showed you. On this one, we'll use our axis of symmetries. The first one, x equals -b over 2 times a would be 8 over 4, which is 2. So therefore, your vertex, plug that in. You're going to get 2 times 4, which is 8, minus 16 is -8, plus 7 is -1. So your vertex is right here. And then we can simply plug in values on each side of that vertex to find us some more points. So let's plug in 1, 0, and -1 maybe. And there's what I got. And then we can simply mirror those points to the other side and connect our dots, and there's our first parabola. And now for our second parabola, again, x equals negative b would be negative 4 over 2 times a, which is negative 1, would be negative 2. So 2 is our x value for a vertex. Plug that in. Make sure you square it first. That's negative 1 times 4, which is negative 4, plus 8, which is 4 minus 2, which is 2. So 2, 2 is the vertex on my second parabola, which is located right there. And let's again make us a table of values. Plug in some values on each side. Again, 1, 0, and negative 1 are smaller numbers and easier to plug in. So let's plug those in. And again, when you plug them in, make sure you square first and then take the negative, and here's what you get. And again, we can simply mirror those to the other side, and here's our three mirrored values. Looks something like that. You can look for patterns if you needed more points. Look, we went down 1 over 1. We went down 3 over 1. We went down 5 over 1. So if you need another point, you could go down 7 over 1. But here's what my parabola looks like. And we're simply worried about points of intersection, which are here and here, which is the point 1, 1 and the point 3, 1. That's it. Number 7. Let's see. The first one, let's use our transformation on this. So we have y equals, let's go ahead and move our 11 over as we're writing it down. So that'll be y plus 11 equals, factor anything in front of the x squared out. That'll be x squared plus 6x now. Leave some space. We're going to complete that square by halving and squaring. So we're going to add 9 to that side. Since the negative's out front, we're going to add a negative 9 to the other side. So our new equation is now y plus 2 equals negative parentheses x plus 3 squared. Move the plus 2 over by doing minus 2. So now there's your transformations. We're going to flip it, and then we're going to move it left 3 and down 2. So every point start at 0, 0. That's on your original y equals x squared, the original parent function. 0, 0. Flip it, move it left 3 and down 2. It moves to here. What used to be at 1, 1, flip it, move it left 1, 2, 3, and down 1, 2. It is now there. And I just noticed my first point is in the wrong spot. I went left 4 instead of left 3. So let's go to negative 1, 1, flip it, move it left 1, 2, 3, and down 2. It is now there. Let's take the point maybe 2, 4, which is here. Flip it, it is now down here. Move it left 1, 2, 3, and down 1, 2. It is now there. So that should be enough points to kind of get us started. We can now use patterns. We can use our symmetry there. So we went down 1 over 1. We went down 3 over 1. So we can go down 1, 2, 3, 4, 5 and over 1. If we needed another point, we could reflect that over. And there is our first parabola. Now our second parabola, x squared minus 4x, it would be really easy to complete the square on that one. So let's do y, leave a little bit of a space, equals, we don't have a constant term to move over. That's the reason it's going to be easy to complete the square. Half it, square it, you're going to add 4. Make sure you do it to both sides. So it's going to be y plus 4 equals x minus 2 squared. When you factor it, move that 4 over. So there you go. This will be simply your y equals x squared parabola moved right 2 down 4. So your 0, 0, move right 2 down 1, 2, 3, 4. There's your vertex. 1, 1 on your original parabola, move right 2 down 1, 2, 3, 4. You can mirror that across your vertex. Let's take the point 2, 4, which is normally here, and move right 2 and down 4. It is now there. You can mirror that across your vertex. And you can kind of see already, once you draw this parabola, that these parabolas don't touch anywhere. There's no points of intersection. So therefore, your solution here, there will be no solutions. There is absolutely no points of intersection between these two parabolas. Next up, y equals x squared minus 3. Much easier to graph that using transformations than any other method. Take your original y equals x squared parabola and move everything down 3 units. So this would be your 1, 1. 2, 4, you could go from your vertex and just go over 2 and up 4. Mirror it. You can go over 3 and up 9, 5, 6, 7, 8, 9. and mirror that to the other side, and that is y equals x squared minus 3. The second parabola, I don't know, we'll graph this one. Again, you can use either method. You can graph this with a t-table. So let's find our vertex and axis of symmetry first. Negative b over 2a, that'd be negative 12 over 2 times negative 2 would be negative 4, so that's x equals 3. So my vertex will be located at 3, comma, let's plug it in. This will be 9. Negative 2 times 9 is negative 18. Let me write this down. Plus 12 times 3 would be plus 36 minus 12. That'll be negative 18 and negative 12 is negative 30. Plus 6 would be 6. Negative 30 plus 36 is 6. So our vertex is located at 1, 2, 3, 1, 2, 3, 4, 5, 6. That's actually one of our points of intersection. There's our vertex. Now we can plug in some values on each side. Again, I like to plug in smaller values. So vertex is located at 3. Let's plug in 2, 1, and 0. And when I plug them in, here's what I get. And we can take those same 3 values and just mirror them over to get more points so we can draw our parabola, which we already see where those intersection points are going to be. But let's go ahead and draw it anyway. And our intersection points will be located here and here. So that would be located at 1, negative 2. And our other one is going to be the vertex of the blue parabola, which was located at 3, 6. Next one. Looks like we have a circle and we have a line. So circles, the general form is x squared plus y squared equals r squared. So this is r squared, so it means that r is 5. The center of our circle has not been shifted any, so the center is at 0, 0, and we're going to go up, down, left, and right 5 units. And there's our circle. Our second one's a line. So we have 3x minus 4y. Let's move that 3x over. And that leaves you with negative 4y equals negative 3x. Divide by negative 4. That gives me y equals 3/4 x. So that's a line that has a y-intercept at 0 and a slope rise 1, 2, 3, run 1, 2, 3, 4, and go down 3 and left 4. And we see already our points of intersection. And that would be here and here on our circle, which would be the points 4, 3. And negative 4, negative 3. Next problem, number 10. We have a parabola, but what's different about this parabola? It's a y squared parabola. So therefore, or actually, this is going to be a sideways parabola. It's going to be flip either left or right. And the way we're going to graph this, you could either get it in the other form, the transformation form, or you could just do a table of values as it is. So what I'm going to do both, a little bit of both. I'm going to first move my plus 4 over, so I now have y squared minus 4 equals negative 4x. Then I'm going to divide everything. This 1 I'm dividing by negative 4, and this I'm also dividing by negative 4, both terms. And that's going to give me, my x is now by itself over there. I'm going to put it on the left side. Negative 1/4 y squared plus 1. So there is your parabola. You can see your vertex. The y in parentheses has not been moved up or down any. This plus 1 is going to move your vertex right 1. So right 1 and up 0, your new vertex is going to be at 1, 0. And you can go back and review transformations if you need to see why that happened. Now, since this is a negative, your p-value here would be 1, or excuse me, negative 1. So this thing should open up to the left. So you can't really get an exact one. So to get more exact points, what you can now do is you could start plugging in some y values, and you can see what x values are associated with it. So notice the reason I'm plugging in here y values is because my equation is solved for x. So I would plug in maybe my axis of symmetry is now because there's my vertex, since it's cupped left and right, I now have a horizontal axis of symmetry. I'm going to plug in y values of maybe 1, 2, and 3. And when I plug those y values in, here's what I get. And I have gone ahead and graphed those. Now you can reflect those across your axis of symmetry, and it'll give you some more points that'll be on this parabola. Whoops. The only issue here is you really want to, since you're doing the negative 1/4 times something, you really want to multiply times something that you know that you can take a fourth of. So maybe we should have plugged in a y value of 4, would have also worked because 4 squared would have gave you a 16. Negative 1/4 of 16 would have been negative 4 plus 1 to give you a negative 3. That would have gave you a little bit better point, so negative 1, 2, 3, 4. And again, we could have reflected that as well, but there is your parabola. Now the second part, 4x squared plus 9y squared equals 36. Notice your x squared and y squared terms. This is a conic section, and since x squared and y squared are the same signs but they're different numbers, this is going to be an ellipse. So what we're going to do is we're going to take, and to set this equal to 1 like we see most ellipses, we're going to divide everything by 36. And that's going to give me x squared over 4 over 36 is 9 on the bottom. 9 over 36 is going to give you a 4 on the bottom, and then 36 over 36 is 1. So there's your ellipse. So it's going to be wider than it is tall because the larger number is under the x. So this is my a squared, so that means that a is 3. So that means because the x is listed over the top, I'm going to, from the center, which this has a center of 0, 0, I should point that out. From the center, you're going to go right 1, 2, 3, and you're going to go left 1, 2, 3. Also from the center, you're going to go up 2 because your b value is 2. You're going to go up 2, and you're going to go down 2, and you can already see what your points of intersection are, but let's draw our ellipse. And your points of intersection will be here and here, which will be at 0, positive 2, and 0, negative 2, so we could actually just write that as 0 and plus and minus 2.